So greetings and welcome to today's educational program, Basics of Root Cause Analysis by James Rooney. This is your moderator, Doug Wood. This webinar is co-sponsored by ASQ's Healthcare and Quality Management Divisions. Today we have the distinct pleasure of hearing from Jim Rooney. Please join me in welcoming him. So Jim Rooney is the Director of Training Solutions for ABS Consulting's Oil, Gas, and Chemical Division. He has 40 years of experience in quality, Lean Six Sigma, reliability engineering, risk assessment, incident investigation, and process safety management. This includes the application of techniques such as fault-tree analysis, failure modes and effects analysis, root cause analysis, and hazard and operability analysis. Rooney received a BS in chemical engineering from the University of Virginia, an ME in nuclear engineering, and an MBA in management operations research from the University of Tennessee. An ASQ Fellow, Rooney sits on the editorial review board of ASQ's Quality Progress magazine and served as the chair of ASQ's board of directors. Jim currently serves as chair of the awards board and past chair of the healthcare division. He holds 10 ASQ certifications. And so without further ado, it is my pleasure to introduce Jim Rooney. Jim, the floor is yours.
Thank you very much, Doug. We've got an audience from around the world, so good morning, good afternoon, good evening, wherever you happen to be. I'd like to welcome you all to this webinar on the basics of root cause analysis. I'd like to thank the Healthcare Division and the Quality Management Division for all the efforts they put forth, especially Doug to help me get set up and to do all of the really effective marketing. So let's do a quick overview. What we're going to talk about today is the definition of root cause analysis. We're going to talk some about approach and scope with respect to root cause analysis. I'm going to hopefully show you guys the task triangle and spend a little bit of time on that concept. We'll talk a little bit about RCA problems and best practices, and then I'll kind of wind it up with an overview of an RCA methodology flowchart. So hopefully when the webinar is done today, you'll understand what it takes to have an effective root cause analysis approach and methodology that you can use at your company. I wanted to start out with a little bit of explanation. I want to make sure that we're all using the same terminology so we have a common vocabulary to discuss root cause analysis and really assist with the asking of questions later on. So let's jump into just a tiny bit of terminology. There are two types of incidents: accidents, also referred to as loss events, and near misses. Accidents are when an unplanned sequence of actions and conditions result in an unacceptable consequence to a system stakeholder. So you can have things such as an injury to a worker, harm to the environment, damage to equipment. Near misses are similar to accidents, but generally don't result in actual losses, but they could have potential losses. An incident can be both an accident and a near miss. For example, an employee can sustain minor injuries or a small amount of hazardous materials could spill, but there still could be a potential for more serious impacts to the individual or to the environment, okay? So for us as root cause analysts, incident investigators, these are the things that we deal with as we do our investigations: accidents and near misses. So what is root cause analysis? Well, it's a structured approach to obtain feedback on the performance of equipment, people, and processes. It's a reactive analysis approach, meaning it's performed in response to a negative event or incidents. And again, those incidents include both accidents and near misses. What we're trying to do here is understand the underlying causes of incidents, and we'll talk more about what we mean by underlying causes. But our true product out of our root cause analysis is to generate corrective actions and preventive actions to prevent and mitigate these incidents. to prevent them from happening again. So just some questions for reflection about your RCA programs, you know, what's going on at your hospital, at your chemical plant, and your manufacturing facilities. These are some of the things that we hear from customers. You know, we do investigations, but we don't get new insights. We kind of go through the motions, but we don't get the results that we need, okay? We don't seem to be learning from experience. The same things seem to happen again and again. We're spending way too much time on investigating unimportant issues. And as a result of that, we don't have time to focus on significant risks. Then some other issues like the investigators jump to the recommendations before thinking through the potential causes and gathering all the right data. They think they know what the answer is. And so this really goes back to the beginning of my presentation. How do you know you have a good RCA methodology? If you do, you shouldn't have these kind of issues, okay? And so we're going to talk a lot about installing the right methodology and getting to the underlying causes. Now, when implemented correctly, we're going to learn a lot about our organization. RCA is focused on the identification and elimination of performance gaps at multiple levels in the organization. And this is what the slide represents. Performance gaps are defined as the difference between desired performance, or what should occur, and the actual performance, or what does occur. So from this task triangle that I'm showing you here, you can see at multiple levels in the organization, we're looking for performance gaps, starting with people and equipment, or working our way down through tasks, processes, management systems, and possibly even to gaps in our company culture, okay? RCA is not effective when it attempts to eliminate performance gaps by directing recommendations at frontline personnel instead of the underlying systems, okay? RCA helps target recommendations towards the underlying systems, towards the processes, towards the management systems. I just don't want to fix one little thing, one piece of equipment. I want to understand what it was about the processes or the management system issues that led to someone having a performance gap or a piece of equipment not performing like we want it to. In terms of scope, it's important to be clear what is in and out of scope in RCA, okay? The thing that is completely out of scope is assigning blame to the individual, assigning blame to a piece of equipment, okay? That gets us absolutely nowhere. We are setting people up for success or failure through our management systems, through our processes. The same thing for pieces of equipment. So what should RCA be used for? To take action that will set those frontline workers up for success and eliminate factors that set frontline workers up for failure. The focus is on making changes to the underlying systems that affect the individual's performance. One recommended change at a lower level in the system can be leveraged to solve numerous issues higher up. Again, never use root cause analysis to blame, okay? Blaming individuals doesn't lead to understanding what caused the incident or change the underlying factors, okay? It just doesn't help in any way, shape, or form. I want to spend some time talking about the task triangle. This seems to be a concept that many quality professionals, root cause analysis root cause analysts aren't really very familiar with. So I do want to spend a little bit of time focusing on the task triangle. The task triangle can be used throughout the root cause process, the investigation process, to think about performance gaps, causes, the depth of investigation, and ultimately developing recommendations. Think of the triangle as an upside-down organization chart. Instead of the CEO at the top, it's the people on the front line. The top of the triangle covers the physical work being done by people in the field, such as operators, mechanics, laborers, technicians, doctors, nurses. The middle of the triangle is support personnel, such as supervisors and support groups. You have groups such as procurement and human resources here. These people help the field personnel by making task and process controls. Task controls include procedures, which help guide the work, equipment and supervision, which ensures work is being done to certain standards. Process controls ensure the task controls are properly implemented. These controls include things like hot work permits, job hazards analysis, stores and spares management, and job scheduling. These processes are managed by support personnel and groups. The bottom of the triangle is management. They establish the management systems and the organizational culture. Management systems influence the performance of people and equipment. These systems include methods to develop training and procedures, design equipment, and determine how work and project planning is performed. These systems are usually managed by facility and organizational management. The bottom of the task triangle is organizational culture. That is set by leadership and generally accepted and carried out by the rest of the organization. So you can see that the culture and the management systems through the controls, the process and the task controls are really setting the field personnel up for either success or failure. And the same thing with equipment. Is it being set up for success, designed correctly, maintained correctly, having trained personnel to fix the equipment? Now that you're oriented with the organizational levels of the triangle, let's review some issues and causes that the model helps us to analyze. In this model, there are 3 levels: causal factors, intermediate causes, and root causes. As the analysis descends through the levels, the level of learning increases and the scope of the corrective actions widens. Okay? I'm going to cover each level in detail, and I'm going to start at the top with causal factors. There are 2 types of causal factors that lead to accidents and near misses: equipment performance gaps, or EPGs, and frontline personnel performance gaps, FLPPGs. An equipment performance gap is when a piece of equipment does not perform as desired. It's not a failure to perform as designed, but failure to perform as desired, okay? So I want to talk about that just for a minute. I can design a pump to deliver 100 gallons per minute, and that pump can deliver that 100 gallons per minute. But if for a certain situation, we need more water to flow to cool a piece of equipment, well, gee whiz, the desired flow might have been 200. We designed it for 100, it performed and gave us 100, but gosh, when we did the design calculations, we didn't do them right, and we didn't realize that the desired performance was 200, okay? Terms used to describe EPGs are equipment fail to, excessive or deficient equipment performance, and shutdown, outage, or lost production. An example of an EPG might be if a bearing fails. The actual performance is that it failed. The desired performance is that the bearing does not fail, okay? Another example is a pump that supplies 80 gallons per minute, which is the actual performance. The desired performance, however, is to supply 65. Remember, the performance gap is the difference between the actual and desired performance, which in this example is 15 gallons per minute. A frontline personnel performance gap is when frontline personnel do not perform as desired. An FLPPG is not a failure to perform as directed, but failure to perform as desired. So my example here is you can give Jim the procedure. Jim can faithfully execute every step in that procedure as directed. But if that procedure is not correct, I'm not going to perform as desired. I'm not going to do everything that's necessary for a particular operation. Terms often used to describe FLPPGs include operator did not or failed to. The doctor did X instead of Y. The technician did X too soon or too late, too much or too little, or too fast or too slow. An example might be an operator should have performed a pre-operational startup test, but decided not to save time. The performance gap is the unperformed startup test. Another example might be an operator starting pump 4, but they should have started pump 5. The gap is the starting of the wrong pump. Causal factors are either EPGs or FLPPGs that caused an incident, allowed an incident to occur, or allowed the consequences of the incident to be more severe than they might have been. There are usually multiple causal factors per incident. For example, the FLPPG of starting pump 4 instead of pump 5 and the EPG of the higher pump rate caused an incident where a tank overflowed. For many of you who might be in the chemical industry or deal with highly hazardous chemicals, I highly recommend that you go to the U.S. Chemical Safety Board site and watch some of their videos. And what you will see again and again is multiple causal factors, multiple equipment performance gaps, multiple frontline personnel performance gaps, resulting in terrible fires and explosions that claim the lives of operators and possibly even the public. And so this is really an example of what it is out in the field, multiple causal factors per incident. So let's go lower in the triangle, okay, to the intermediate causes. There are underlying reasons why a causal factor occurred, but they're not deep enough yet to be a root cause, okay? They're an explanation of the causal factor, but it doesn't get us down to a management system performance gap. So intermediate causes typically involve design, maintenance, analysis, human factors, procedures, training, and communication. Recall our causal factor examples where the pump rate was higher than desired and the operator started the wrong pump. That operator may have turned on the wrong pump because of a deficient procedure or possibly ineffective training. The pump may have pumped at a higher rate than desired because of a poor design or replacement of a component with an insufficient spare part. So we've explained some about how the equipment or frontline personnel performance gap has occurred, okay? But we haven't really gotten to the point where we've gotten down to a management system, a business process. Root causes are the underlying causes of causal factors. They're management system performance gaps, MSPGs. For every causal factor, there are usually 1 to 4 root causes. Root causes are typically issues involving policies, systems, processes, guidelines, standards, methods, and other management system process. An example of a root cause would be that there is no policy limiting overtime work of personnel, or there is no policy requiring field verification of procedures prior to use. Another example is the policy requiring field verification of procedures is not enforced, okay? And so the management system gaps lead to intermediate causes, lead to causal factors. And so a quick little example here is our management system gap is we don't walk down procedures, we don't do a field verification. Our task control and process control issue as a result of that is we have a deficient procedure. The frontline personnel performance gap is as a result of that deficient procedure, Jim fails to take a sample, okay? So Jim failing to take a sample comes from the procedural deficiency, which comes from the fact that we have a gap in our management system. We don't walk down procedures. So, returning to our previous example, the management system performance gap is the lack of a procedure requiring field personnel to verify procedures are adequate prior to use of the procedure. That lack of procedure verification led to the deficient pump startup procedure, and that ultimately led to the operator starting pump 4 instead of pump 5, okay? And so, again, our focus here is not on blaming the operator for starting the wrong pump, okay? Our focus is on the process control, the management system issues, and fixing those. So if we have the correct procedure, that will help all operators start the correct pump. Let's talk a little bit about some common RCA problems and some best practices. These are some of the common RCA program problems that we see. Delaying the start of an investigation, okay? The longer you wait, the harder the investigation becomes. People forget, data is inadvertently destroyed, and then the worst thing of all happens. The person that we all respect the most says, I think it happened that way. And that subtly influences all of us to that person's point of view. It's not done maliciously. It's done in the spirit of, let's figure out how to get this done. We put together an ineffective team. People who don't know how to identify causal factors, don't understand what root causes are, they don't know how to write recommendations, they don't know how to analyze data. Lots of issues there. Failing to have a program champion. Who is it in management, senior management at our facility, and possibly even higher in the corporation, who champions this program, okay? Who speaks highly of it and removes roadblocks for us. If you don't connect your RCA program with business needs, it's not going to help, okay? The goal of RCA is to remove the roadblocks and make sure that we can make product, we can serve our customers, and the organization can make money and be an ongoing contributor to society, to our employees and our customers. Using the process to punish rather than improve, okay? I just can't say enough about if you punish people, it just doesn't help, okay? if you make a math error in your checkbook and I punish you, I'm sure that punishment is going to help you never ever make another math error in your checkbook, okay? And if I give, if you make a mistake at work and I give you the worst jobs to do and I put you on the worst shift, I'm sure that's going to help everybody else's attitude too. The next one, investigating too many or too few incidents, okay? Obviously, if you don't investigate things that you need, you're missing a great opportunity to learn. But you can't investigate everything. It takes too much time, it takes too much money, and really there shouldn't be that much opportunity to learn from a lot of events that have small consequences. I'll talk a little bit about this later on, but essentially if you investigate everything, then you're spending all your manpower doing the investigation, writing recommendations, and ultimately trying to implement recommendations that really don't have any payback for the business. So we really need to have criteria that are kind of preset that help us decide how to, what we should investigate and how many of them there should be. So let me see here. Just check my quick little notes. Make sure I didn't skip anything here. Good. I got everything there. Good. So let's talk about the characteristics of a good RCA methodology. And there are many good methodologies out there, okay? The first issue is that companies have to rigorously use their good RCA methodology as it was designed, okay? And so that really is one of the biggest problems that I see in industry is companies just don't rigorously use the methodology or they misuse it. So for you, how can you determine whether or not the methodology you're using is good? Well, there are a number of characteristics that you can kind of assess of your methodology. Is it easy to learn and apply? Methodologies can be extremely thorough and rigorous, but if they're too cumbersome and time-consuming, they won't be followed as designed, okay? So they've got to be easy to learn and easy to apply. Is the methodology flexible enough to address a range of potential investigation needs? It should work with minor incidents requiring simple investigations and severe incidents requiring more complex analysis. The word I like to use here is the methodology scalable, okay? So I can apply this methodology along a whole spectrum of events from the most minor to the most complex with the highest consequences. I don't need to bring in the expert in some specific methodology for a specific kind of event. My methodology is flexible enough to do that. Does it help the investigators to ask the right questions and gather the right data, okay? And so that's what you want your methodology to do, to really uncover some issues from the data and then guide the investigators to go back and probe the right areas and ask the right questions and gather the right data, okay? You don't want a methodology where you basically feel like, okay, I have to interview everyone who was on shift, on, Monday morning, got to talk to everybody. No, I want a methodology that helps me pare down who I need to talk to, what I need to do to gather data. Does it effectively communicate the results of the analysis to those who are tasked with implementing the recommendations, okay? I need to make sure that the recommendations track back to the root causes, the intermediate causes, and ultimately to the causal factors, okay? Because if the people doing the recommendations don't understand that, they will have no rationale as to why they're doing what you're asking them to do. It has to provide feedback, okay, to the investigators, okay, about how well the investigation was done. So let me do a couple of more slides here that hopefully, with some graphics, bring some of these ideas, into focus. Good methodologies connect causal factors, root causes, and recommendations, okay? And so this is really conceptually what I want to have happen. I have my incident, I determine my causal factors. For that causal factor at the top in gray, I determine what the root cause is, the management system performance gap, and then I write recommendations that deal with the root cause, the intermediate cause, the causal factors. If everyone can understand this flow path, the rationale for the recommendations, it's much more likely that your recommendations will be approved and that your recommendations will be implemented. So you really want to make sure whatever methodology you pick, it does this. So let's talk a little bit about an RCA process, kind of a methodology flow chart. And again, I'm trying to keep things relatively generic here for any methodology that you might choose. And so this is kind of the methodology that I follow, my company follows, and I think it's a good general methodology for everyone. For the purposes of this, I'm going to focus primarily on the gray path, the single event analysis, okay? And so initially, there's some type of incident that occurs, an accident or a near miss. As a result of that, okay, we're going to generate a corrective action request or some type of incident report. As a result of that, there might be no need for any formal analysis. We might decide that this is a slip, a trip, a fall, and it's better taken care of by the industrial safety process. And that's where we would go from there. But ultimately, we need to have some type of process there in that diamond, analyze now, okay? We need to set criteria up about what we're going to analyze and what we're not going to analyze. And in fact, as we think about what we're going to analyze, I would like to be able to give to my investigator an idea of how much effort they're expected to put into this analysis, okay? If we've had some type of massive quality failure with tons of product that's been shipped out that's contaminated, I'm going to expect that we're going to spend a lot of time on that, okay? We might have a very large team. We might spend a week or a month analyzing it. Some other event with, a small leak of a toxic material from a valve, I'm not going to expect that we're going to take weeks and months. I might expect a week or two, one or two people to lead the team. But again, I want this analyzed now to make a decision about if we're going to analyze it and a rough estimate of how big we expect this to be, okay? In initiating the investigation, we're going to pick our team, we're going to pick our investigation leader, and the people that are going to help that person, okay? Hopefully, during initiate the investigation, we're also going to think some about the analytical scope of our investigation and the physical scope. From an analytical standpoint, I like to point out things like big catastrophes, okay? Fires, explosions, releases of material are all are consequences of some catastrophe in a chemical plant. From my analytical scope, what am I investigating? Am I investigating the fire, the explosion, the release of chemicals, all three of those? Am I investigating the adequacy of my emergency response? Okay. So again, to go back to my quality example, producing a lot of product that's contaminated, I probably wanted to have that as my investigation, but is the adequacy of my recall process part of that investigation? We're also going to think about the physical scope, okay? What pieces of equipment are involved? what people are involved. At this point, my team should have an idea of how many people are on the team, what the analytical scope is, what the physical scope is, and how much time and effort they're expected. And again, for a really big investigation, I'm expecting a team charter to set all that. But this really is going to get us to push into Section 3, gather data. I just want to hit relatively quickly this concept that there are, this is an artificial construct. It's just one way to kind of divide the universe of data up. Okay, you may have one that you like. This is the one I like. Okay, there are 4 kinds of data: people, position, physical, and then what used to be paper and now is electronic. Okay, and so these are the kind of pieces of data that you and your team are going to have to deal with. The paper electronic includes process logs, maintenance logs, procedures, written communications. Physical includes gathering and taking pictures of key equipment and parts, and actually possibly doing some testing on those, okay? Non-destructive testing, destructive testing. People, what does that mean? Oops, sorry about that. People. We're going to have to interview witnesses and others who were involved. People are a fantastic source of data, okay? You have to get to them very quickly before they begin to think too much about what happened and begin to rationalize. But people are a great source of data. Position data, it's related to the physical and people data and includes documenting the locations of people, the location and size of scratches and marks, valve and switch positions, and tank levels, okay? So where are people as a function of time during this fire or explosion? People just don't randomly appear and disappear. They're always somewhere, okay? And so I did write a column for Quality Progress Magazine on data collection that's available, just kind of let you know that. After we gather the data, we have to analyze the data, okay? And so we're here in the middle, okay? We are going to analyze data, and the whole purpose of data analysis is to get us the causal factors, the equipment performance gaps, and the frontline personnel performance gaps, okay? There are a lot of tools that are out there that you can use to analyze data, okay? I'm going to talk about 2 in particular that I like to use that, again, to me are scalable. And to me, that's the key. I can use these tools on small events. I can use them on really large, complex events. And those are the timeline and the cause and effect tree. And so let's talk about a timeline. It's a written or graphical description of the time sequence of contributing events associated with an incident, okay? I really should just have graphical description, and I'll show you one here in a minute. I've only got one company left that I know of that does a written timeline, and won't tell you who it is, but it's a German chemical company that's been using timelines for like 30 years in a written format, and they love it that way, and they're never going to change. For the rest of us, I'll show you the graphical. There are some very specific elements in a timeline. The loss event, okay? What is the accident that I'm investigating? I need to think about the actors, the people, the equipment, the parameters involved. I'm going to put events and conditions up, and I can put questions up on this. And for us, I'll show you this, and I'll talk about it. This is an example timeline. Now, we use a really, really high-tech method to develop timelines, okay? And so we use 3M sticky notes, okay? And so sticky notes are perfect for this because sticky notes allow you to rearrange this timeline when you learn things about it. But I just want to kind of show this as an example. You can see the blue rectangle there, kind of a little bit to the right-hand side. That's our loss event. The forklift hit the wall, causing damage. How do we know that? Employee number 2 told us that, and it happened 1 minute afterwards, okay, after the previous event. You can see there on the left-hand side the actors, employee 1, employee 2, the forklift, and then an employee named Raymond. And essentially, as you go across the horizontal lines, you can see what employee 1 did as a function of time, what employee 2 did as a function of time, what happened with the forklift, and what Raymond was doing. So essentially, if you look at this timeline, employee 1 parked the forklift near the storage rack to go to the restroom. Employee 1 told us that. It happened on April 20th, 2009, about 3 p.m. The forklift's condition at that time was that employee 1 forgot to set the parking brake on the forklift, okay? Again, same date, same time, employee 1 told us that. The next thing that happened, employee 2 drove Raymond past the storage racks on the way to the loading docks. That happened. Raymond hit the forklift hit the wall, causing damage. Ultimately, employee 1 returned to the forklift, and employee 2 reported the incident to the supervisor. It's a very nice graphical way to explain exactly what happened. And we can do this model and basically realize that our causal factors were right there on the model. Employee 1 parked the forklift near the storage rack to go to the restroom. Employee 1 forgot to set the parking brake, and then employee 2 drove by on the way to the loading docks. It's a very fantastic tool, team-oriented, and again, it's visual and graphic. The other thing that you can see as you draw one of these are gaps, okay? So big time gaps. I have to fill in the big time gaps, but it is a great tool, okay, especially when you have a lot of people involved in an activity. Fault tree analysis. Here in the Knoxville office where I reside, many of us went to graduate school at the University of Tennessee. And when we were there, we spent a year taking a class where we drew fault trees, and we did all kinds of things with fault trees. So this place is just fault tree heaven here. If you want to think about fault tree analysis, some people call them logic models, Boolean algebra models. It's the 5 whys with logic, okay? That's really what it is. It's a great tool, especially for equipment failures. You begin with a known event and describe possible combinations of events and conditions that lead to the event. It's great for troubleshooting. In fact, you can use it to develop troubleshooting guides, and it's great for structured guessing. What it kind of does is it looks backward in time to describe and identify potential causes. I like it because it uses and or logic to show the causes and the combinations of causes. So this is a great tool when you need 2, 3, and 4 things to go wrong to have a failure. To really show that you fulfill the logic, it really is good. Now, there is a difference here. When I learned to draw fault trees, we did them kind of in a proactive analysis rather than a reactive RCA analysis. So we drew the biggest possible tree. I don't want to do that for a root cause analysis. I want to draw the smallest possible tree that we can. So one of the great things about using fault tree analysis, cause and effect trees in root cause analysis, is if I can get to a point in the development of the tree where I can show that something didn't happen. With data, I don't have to develop that branch. So it can really help speed up the analysis. Same kind of idea here. The goal is to identify performance gaps of equipment and frontline personnel. This is a quick little tree. I'm not going to go through this in as much detail as I did with the timeline, but you can see here at the top, our loss event is incorrect gas delivered to the patient. That took two things to go wrong. That has an AND gate. Incorrect gas delivered through the system and the error not detected at the patient location, okay? And so it's just like a 5 whys. We ask the why questions, thinking about, you know, is it an or where any one of the inputs can cause something to go wrong, or is it an and where I require two things? I do want to point out here on the right-hand side there, we've got error not detected at the patient location. You can see that we brainstormed a number of different ideas there. No indication of wrong gas, indication of wrong gas not detected, and corrective action insufficient. Well, for two of those, I'm going to drop the universal no symbol on top of them. That means I have data to prove that those events did not occur. So I'm not going to develop them anymore. But the no indication of a wrong gas, I'm going to ask questions about that one. And I'm going to get down to oxygen monitor not used. I really like timelines and cause and effect trees. They're scalable. They're very powerful. Another technique that a lot of people like to use is causal factor charting. It, again, is a very powerful technique. It somewhat combines the logic from cause and effect trees with the graphical approach of the timeline, time-oriented. So it's a great tool. It's a little harder to teach. It's a little harder to implement, but it's still a good technique. But if you look down the parameters for cause and effect tree analysis, you can see that it's really good for acute and chronic incidents. It's really fantastic for equipment and hardware, okay? Timeline, it's good for acute. It's really good for people-oriented problems and incidents where timing is important. And so to me, if you can learn to do cause and effect trees and timelines, you can solve almost any problem. Again, each method has strengths and weaknesses. I'm not going to spend a lot of time going into them, but fault trees do have issues where timing is important. Timelines are difficult to use if you're doing chronic incidents. In the end, though, if you get good with either of those two techniques, cause and effect tree or timeline, you can solve any problem with either technique, okay? So there really isn't, you know, a reason to go anywhere else, you know, once you get good with one of these. After I get my causal factors, my equipment performance gaps, and my frontline personnel performance gaps through the trees or the timelines, I then have to come up with a methodology to identify root causes. When Doug and I talked about this presentation, one of the things that I wanted to do was keep it in a very generic kind of mode and not push any one methodology, any one technique over another, especially anything that might be proprietary. There are a lot of different ways to get root causes. I'm going to show the method that we use. This is really related to the U.S. Department of Energy's MORT technique, Management and Oversight Risk Trees. There are a number of similar maps that are out there. And if you want a copy of this map, I'll be glad to give it to you, okay? So again, we're not holding it hostage in any way, shape, or form. It's really kind of a graphical checklist where you start with your causal factor and you ask a number of questions and work your way down from the causal factor to intermediate causes and ultimately to root causes. Many of these maps have similar organization. There's an area on the map that deals primarily with equipment. So those are things like design, equipment reliability, parts. There's another section of the map that you can use to organize to identify people-oriented intermediate causes, procedures, training, human factors, supervision. There are a couple of catch-alls at the top for natural phenomena and a few other things that are rarely used. There's a section on the map where people have personal performance issues. So again, things like horseplay, drug use, things that you and your company can't control. There's an area for that. And then there's an area for root causes that really talk about, you know, management system performance gaps, non-existent management systems, incorrect management systems, inadequate management systems. Again, it's a graphical checklist. It's very easy to use, very straightforward. There are lots of different ways to identify root causes, okay? Just kind of trying to give you one example. But after that, we are now in our most important area. We've got to develop recommendations, okay? And so I really want to hit this because I think this is one of the most important things that root cause analysts forget about, okay? 4 levels of recommendation. I want to address the causal factor. If it's broke, I fix it. I return to operation. It's really not even on the root cause map. It's kind of a rewording of the causal factor. The bearing failed. Replace the bearing. Relatively straightforward. Address the intermediate causes of the specific problem. For the procedure involved in this incident, fix the procedure, whatever the specifics are. I'm going to jump down to number 4, correct the process, okay? So I'll go back to my example. The causal factor, Jim failed to take a sample. Well, let's take a sample. What's the intermediate cause? There was a procedure with deficiencies. Fix that procedure. The 4th level is to create the process, is to correct the process. So let's fix the procedure writing guidelines so we walk down procedures with significant operational impact, so we don't have procedures that have errors in it. I could talk for 2 or 3 hours about level 3s, okay? Fix similar problems. The idea here is I need to look around and see if there are similar issues in my facility or elsewhere in the company. The level of effort that you spend on the level 3s is really risk-related, okay? If I think that there's a lot of issues that could have either severe consequences or the sum of those consequences could be really bad, I'm going to spend a lot of time looking for these things, okay? So if I think that there's a lot of procedures that have deficiencies and the consequences are pretty bad, I'm going to spend a lot of time looking for them and fixing them. If, on the other hand, I say the risk is very low, there are not many procedures like that, the consequences are low, I'm not going to spend any time. But again, not just focusing on fixing the person, fixing the piece of equipment, but fixing the business process that caused it. ASQ has on its website kind of a compendium of root cause analysis resources, okay? It's got links to courses like the one that Duke Oaks and Doug teach that ASQ has. It's got papers. It's got links to books you can buy. Lots of it's free. I highly recommend that you go there and, you know, see what's available that may be of interest to you. So what do I want you to take away from this webinar? RCA is a structured method to obtain feedback on the performance of equipment, people, and processes, okay? It's not about blame. It's about setting the equipment and the people up for success by having the right processes in place, okay? And so when you think about it, when you think about ISO 9000, 14,000, 45,000, I could go on, okay? those management systems, what do we want to do with them? We want to optimize those management systems to set our people up for success. The task triangle is a great tool that you can use throughout the investigation process to think about performance gaps, causes, do I want to go deeper, and also about developing recommendations. And again, those 4 levels of recommendations are really important. Many RCA problems that companies experience are due to ineffective investigation team, not having the right people, the right leader, people who, you need people who need the tools. Failing to demonstrate the value of root cause analysis to the business, okay? How is this helping us have better reliability, better quality, and make more money? And ultimately, failing to rigorously follow a good methodology. Many companies select a methodology that works for them, and then they fail to follow it, okay? And so if you've got policies and procedures on how to do an investigation, you need to follow those policies and procedures so you can see what issues there are with those management system documents and improve them. This is my contact information. If you want to reach out to me via email, call me. I will warn you, I am teaching all this week, and so I'm going to be really hard to get by a phone this week. I'll be around next week. But if there's something that I've mentioned that you want, you have a question, you want the RCA map, I have templates for drawing trees and timelines, again, that are available for free. Just let me know. I want to thank you all for your attention. Again, I want to thank both the Healthcare Division and the Quality Management Division for sponsoring this and the great job they did in setting it up and advertising it. And again, deep personal thanks to Doug Wood for all the help he gave me in, setting this up, looking over my presentation, and being here to help run it. So, Doug, I think it's time to turn it back over to you.
Thanks, Jim. Yeah, that's great. I wanted folks here to remember, we're running a little over, but I still think we'd like to do some Q&A. So don't leave yet, guys. We've got a couple questions here that I think Jim might be able to answer. And I've been collecting them as we went. I haven't been able to actually, answer all of your questions online. So let's see here. What do we have? One of them was, so software. Is there a software you would recommend for administration of root cause analysis?
That's an interesting question. It depends on, let me break that up into 2 pieces. There are a number of softwares out there that really have to do with more of the administration side, which is, capturing the document and really being a recommendation tracker. I think there are a lot of good ones out there. On the other hand, when you talk about software to actually execute the root cause analysis, I mean, the one that always comes to mind, and they're a competitor of ours, and they're one exit down the interstate, and a lot of people use them and love them, is Taproot, okay? Regardless, if you're going to use a software for doing root cause analysis, you need to think about what the pluses and what the minuses are. One of the great advantages of software is that it really does impose a lot of rigor on your investigation at a loss of flexibility, okay? And so if you have a lot of people doing investigations of low consequence events, software may be very helpful. On the other hand, if you are investigating, what I call non-standard events of medium to high consequences, the software may put a straitjacket on the creativity and brainstorming of your investigators.
Okay, thanks. Okay, couple other just come in. So here's a question. I suppose you're suggesting that Some cases, a paper tracking system or manual might be better than an electronic control system, but it really depends on the organization's discipline. Is that true?
Yes, yes. I know very many companies that do all their tracking in Excel. Okay, I mean, they track investigations in Excel, they track recommendations in Excel, and they keep everything in SharePoint. So again, I said, Doug, I think you nailed it there, is how good is your discipline, okay? If as a company you're very disciplined and, you know, putting things in Excel, sending out emails, you know, manually works for you guys, that's fine. I will say there are many organizations that I've come upon that are not very disciplined, and they truly need an automatic system to record the incident investigation and the recommendations, and they need what I call badger mail that issues, you know, badger notices that, you know, hey, Jim, you haven't submitted your root cause analysis, it's overdue. Hey, Jim, you haven't done your recommendation. So again, you know, you need to think about what your culture is, how much rigor and how much discipline you can provide as an organization, or you need software to provide.
Okay, thanks. One question from Tian. He says, I've been told that fishbone is not a very good RCA methodology. Would you agree with that assessment based on your flow chart? And again, fishbone, yeah, everybody says they do fishbone, and I hear that too. What do you think about that?
Okay, I'm going to go no on fishbone for one primary reason, is that it does somewhat limit your brainstorming, and it really doesn't help you get to the answer. If I'm a subject matter expert in this area, I may be able to use something like a fishbone to get to the answer. But if I'm not a subject matter expert, or it's something that's occurred that's outside of my experience, a fishbone's not going to help me. So something like a tree or a timeline where I can see the gaps in time or the gaps in logic and I know where to fill in, those help. To me, I've seen groups who have told me we're going to use the fishbone to start, and they sit around and stare at the fishbone for an hour or two, and nobody has anything to contribute. So, I mean, I think it's a great visual tool, maybe for reporting information, but I don't find it a great analysis tool.
Okay, great. So one final question here, I think, was really good. What do you recommend if recommendations to change a management system or company culture? And you know, you found that that's a contributing cause or major cause, and that gets pushed back. You know, so what would you suggest that they do there?
Well, okay. So I'm definitely going to tell you that making changes in management systems is a difficult thing to do, okay? It's not as easy and straightforward as all the other level 1, 2s, and 3s recommendation. And so to me, the first thing you have to do is you have to show that connection, okay? Why am I asking for this change in the management system, okay? It's going to link back to, it's going to prevent these root causes. It's going to prevent these intermediate causes. It's going to present that causal factor. And so I want to make sure that I can demonstrate, you know, what impact this change in the management system is going to do. But I can tell you, people push back, and many times their answer is, it's hard. Okay, it's hard. I have to convince all these people to do it. Then I have to make this change. It has to go before management. Then I'm going to have to train all you guys on this new stuff. And so people push back just because they're hard. To me, if you can demonstrate the benefit of that management system change, you've got to go for it, okay? The other thing is, when you make those changes, you're making fixes across large swaths of the organization. If I fix my procedure writing guidelines, then I am correcting procedures that exist now. I am preventing errors in procedures that we've never even written. And so you really need to lay out the case for the management system change. But I agree. It's a hard thing to do. It's a hard thing to convince people. But again, if you're using that methodology that links the causal factors, intermediate causes, root causes, and recommendations, that should at least give you a skeleton of this is why I think we ought to do this.
Okay, and just one more. Okay, I've got to ask this, and a number of people have been asking this. What's your thought about the 5 whys approach? Is it good for simple?
I knew somebody was going to ask that evil question. Okay, so I'm going to give you Jim's answer. 5 whys is a good approach. I never use it. Now, I can't use it, okay, because I'm not an SME in the process. So when I ask the why question, I can't answer it. Now, I have another couple of reasons that I don't like the 5 whys. And it's not the methodology per se, but 5 whys is presented as I can teach this to almost anybody and they can be an effective root cause analyst. And I truly don't believe it because there isn't very much structure to a 5 whys. And so now I'm taking someone who is a neophyte in root cause analysis and I'm asking them to solve a problem with a methodology that doesn't provide them any structure. Okay, and so it just doesn't seem to work for those kind of people. The other reason that I don't like it as a pure methodology is, especially for the neophytes, but even for people who have some experience, they can use the 5 whys to ask the question to get to the causal factors, to the equipment performance gaps and the frontline personnel performance gaps. But using the 5 whys to get to intermediate causes and root causes seems to be very difficult for a lot of people. And again, it's the fact that there's no structure. And so that's why a number of methodologies have moved to the root cause map kind of idea. Because what is it? It's a 5 whys kind of approach where you take the causal factor and then use that tree to kind of ask the 5 whys. So, I mean, I will teach 5 whys, you know, and again, for relatively easy, low consequence events where I have access to an SME, you can use it. But I think it's kind of sold as it's easy, I can teach it to anybody and I can make you effective in 30 seconds or, you know, a half a day. And I don't think that's true. Sorry.
Okay, Jim. Thanks. That fits with what I've seen as well. Okay. So
thank you for bailing me out.
No, absolutely. So we're gonna go here to a little bit of closing now.